Hello, and welcome to 3.4, Day 2, Solving Quadratics. In this lesson, we're going to go through and solve different quadratic equations using one of the four methods listed here. Factoring, using square roots, completing the square, and/or quadratic formula. Each question kind of lends itself to a certain type of problem that we can use. Using completing the square quadratic formula can either be done, but we'll learn tricks about each of them. The first thing I would say that we should look for is to see if we can factor. For the first one, we have to think, is there two factors of negative 10 that add to give us negative 3? In this case, there is. It's negative 5 and positive 2. If we then solve that using the zero product property, we would get x equals 5 and x equals negative 2. Factoring should be the first thing we look for because it will save us time as we go through these problems. The next problem, if we start off by thinking about factoring, we don't have two factors of negative 5 that will add to give us 8, so that's out. We don't want to use square roots because we have a bx term. So that leaves us with either completing the square or quadratic formula. For me, if I see my b is even, I like to use completing the square. So my b is 8, b over 2 is 4, and b over 2 squared is 16. When I go through and solve this, I need to get my bx term, or my a squared and my bx term on the same side, and my constant to the other side. If I do that, I can now add 16 to each side, or my b over 2 squared term, to complete the square. If we do this step here will factor to x plus 4 squared equals 21. Now, similar to using square roots, we can take the square root of each side and be left with x plus 4 equals plus or minus the square root of 21. When we solve for x, that would be negative 4 plus or minus the square root of 21. All right, we can go through and get that as an approximation, but for this example, we'll leave it just like that. All right. So that brings us to our next two problems. All right, when we look at number 3, we would have to use the AC method, and we need factors of 75 that combine to give us 6. I'll give you a hint, there aren't any. All right, so when we go through and do this, okay, please remember as we do that, we're probably now either going to use quadratic formula or completing the square. When we do this, completing the square doesn't really work out because they all don't have a common term that we can divide here. All right, so in this case here, I'm going to use the quadratic formula. When we use the quadratic formula, we would say our a is 3, our b is negative 6, and our c is 25. When we go through and solve this, we would now say x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. When we simplify this, this will be 6 plus or minus 36 minus 300 all over 6. All right. When we continue to simplify, we would have negative 264 over 6. And now we need to simplify negative 264. Well, when we do this, this will be 4 times the square root of 66 times negative 1, which will give us 6 plus or minus, right, you can see here I simplified it, 2i times the square root of 66 all over 6. Now, when we go through, we notice that the 6, the 2, and the 6 all have a 2 in common. So when we do this, we can simplify this even further and say x equals 3 plus or minus I times the square root of 66 all over 3. So that will be our answer to number 3. Okay. When we look at number 4, we can't factor this, but if we notice here, there's no just x term or bx term, so we can use square roots. To solve using square roots, we're going to get the thing that's squared by itself. We subtract the 75, then divide by 3. We get x squared equals negative 25. We take the square root of each side, and we get x equals plus or minus 5i. Okay? So those are some helpful hints to go through and realize what we can do to solve these different forms. All right? So our last 4 problems that we have here, on the back, we have x squared minus 4x plus 8. Once again, I can't get 2 factors of 8 that add to give me 4, but I realize my b is even, so I'm going to use completing the square again. My b is negative 4, b over 2 is negative 2, and b over 2 squared is 4. So this is what I'm going to add to each side of my equation. When we complete the square, we want our ax term and our bx on one side and our constant on the other. We then add our b over 2 squared, which is 4, to complete the square. We now factor each side, or we factor the left-hand side, so x minus 2 squared equals negative 4. Now, we can see we have our thing that's squared by itself. We take the square root of each side, and we get x minus 2 equals plus or minus the square root of negative 4. If we simplify the square root of negative 4, it will be 2i. We add the 2 to each side. We have x equals plus or minus, or x equals, 2 plus or minus 2i. Okay. So the more we practice this, the more we realize which method we can use to do this. All right. When we look at number 6, I want to go through. Our a is something other than 1, so we can think about 2 times negative 6, using the AC method, would be negative 12. Do we have factors of negative 12 that have a difference of 1? Yes, negative 4 and 3. So I'm going to solve this one by factoring. When we factor this thing, using the AC method, we would group the first and second terms and the third and fourth terms and pull out a GCF. When we pull out our GCF here, our first parenthesis, they have a 2x in common. That leaves us with x minus 2. We want our parentheses to be the same, so we're hoping we can get the same term here. If we factor out a 3, that leaves us with x minus 2. If you now notice, we have the same terms here. All right, so we can factor that out. X minus 2 equals, let me just grab this other highlighter, 2x and positive 3. So that is our other parenthesis. We would then use the zero product property, and we would say x equals 2 and x equals negative 3/2. Okay. Now, please understand, for some of these, you can use different methods to solve them. I'm just trying to use the ones that can save us the most time. All right. Our last 2 problems. For our last 2 problems, all right, once again, I'm going to look. Well, I have this negative out in front. We don't always factor with a negative. It has a bx term. All right, so we can't use square roots. So for this one, we could either use completing the square, or just because of the negative, I'm going to use quadratic formula. So I would say my A is -1, my B is 2, and my C is 12. So we'd say x equals -b plus or minus b squared minus 4ac all over 2a. When we go through and simplify, we would do 2 squared, which is 4. -4 times -1 is 4, times 12 is 48. So we'd have -2 plus or minus 52 over -2. When we look at this, we realize that 52 can be simplified. Well, what multiplies to give us 52? 4 and 13. So that would give us 2 times the square root of 13. So we'd have 2 plus or minus 2 square roots of 13 all over -2. Now once again, we realize that these numbers all have something in common. What does -2, 2, and -2 have in common? I'm going to factor out a -2, so that leaves me with 1 plus or minus the square root of 13. Okay. Like I said, this could be done using completing the square, but because of the negative, I like to use quadratic formula. All right. Our last one, if we notice here, we have a quantity that's squared. Anytime we see that in no x term, we're going to use square roots. To use square roots, we need to get the term that's squared by itself. So our first step is to subtract the 5. We need to divide everything by -3. Now, the quantity that's squared is by itself. We take the square root of each side. We would now have 2x plus 1 equals plus or minus 3. We subtract the 1, and then we divide everything by 2. So our answer is -1 plus or minus 3 all over 2. All right. This is an acceptable answer. If you wanted to simplify it into our 2 answers, you could get x equals 1 and x equals -2. Depending what your teacher would like, either of these 2 terms here would be acceptable. Okay. That is today's lesson. If you have any questions, please let us know. Other than that, have a great day, and we'll see you soon.